Hello developers, it is one of the most important interview question which is normally asked during the data structure interviews. The problem statement is the two arrays are given and those are sorted from left to right side. Like the array 1 is given and it is sorted from left to right 1, 3, 4, 5, and similarly array 2 is also given which is sorted from left to right. The problem statement is we need to merge these two arrays and the output should be also sorted one. So the output you can see it is also sorted. And the problem is that both of the arrays can be of different size. It means that a left array can be of a different size and right array can be of different size. So the size can be increased. And the array 2 can be of like 7 size and array 1 can be of size 4. So it is not guaranteed that both of the arrays will be of similar size. And one more thing, that the array should be sorted from left to right. So it means that the output will be also sorted in the ascending order in this problem statement. So let's see that how can we solve the problem, and first of all we will actually review the thought process of building up the logic. So let's review the thought process of solving this problem. In this problem, definitely we will create the resultant array. That will be the empty array. We call it the result variable and it must contain the array of size n plus n2. These are the sizes of both arrays, n1 plus n2. I will call it n1, this array number left side, and n2, array of right side. And for solving this problem, we will actually iterate both of the arrays at a similar time. It means that simultaneously we will be actually iterating both of these arrays. So that's why I would recommend to use the while loop in this problem. But how can we use this loop? So that's the question. We will actually create a pointer with the name I on our left side of this array and the pointer j on right array. So it means that we will iterate both of these arrays. First of all, we will iterate, but we will compare each integer of both arrays. So we will iterate like with this condition, like I should be less than n1 and j should always be less than n2. We would like iterate inside these arrays. So that's why the size I should always less than n1 and j always should be less than n2. So we will iterate both of these arrays. But while iterating these arrays, we will compare each integer. So we will compare each integer because I did not use any increment here or anything here. It means that array I element integer which we will compare. So here we will compare if I is less than 2. If it is less than 2, then we will push it into our resultant array, that is 1. In this case it will be of course 1, and we will actually increment the pointer. We will increment our index here. So it will be the I here, and that's why we will increment I plus plus in our case because it is less than 2. So it means I is actually will be incremented, so it will be in this position which is index number 1. So here I will be the position, j would be there. So we will compare again. 3 is less than 2. We will again iterate it. As 3 is less than 2, it will not happen because 3 is not less than 2. So in this case j will be incremented and we will actually push the integer value 2 into our resultant array. And similar case, the index is now at the position 1 of array 2 and the element number is 6. So we will compare again. 3 is less than 6 or not. Since 3 is less than 6, so I will be incremented in this case. And we will push 3 into our resultant array. And we will compare now our our pointer is at index number 2. It means at the position number 2. So I will be here. When I will be here and j will be on the index 1, we will compare again. We will compare 3, of course it will be here. So we will compare 4 is less than 6 or not. Of course it's less than 6. So 4 will be pushed into our resultant array. And our index will be, our pointer will be actually pointing to index number 4. So pointer will be here. So we will again compare 5. Is it less than 6? Of course it's less than 6. So 5 will be actually pushed in our resultant array. And now we, in this case, because I will be actually increment again and then the value, and this condition would not satisfy, so it will go out of the loop. Why it is not satisfied? Because I is now equal to n1, not less than n1. So what happened in that case? So in that case we will actually have our remaining values of these 3 values, 6, 7, 8 in second array. So in that case the remaining values, which can be either in the left side of array or can be on the right side of array, will be actually pushed into the resultant array. As we know that these values are already sorted, so we don't need to create another condition or comparing these values with any number. So we will push them directly. So here 6, 7, 8 will be pushed directly into our resultant array. So that's a trick here, that after iterating over the whole loop, we will actually can be left out with the remaining integers, and those integers can be pushed into the resultant array. It can either be the left side of array, it means that it can be n1 array or n2 array. Both of these arrays can be, any one of these arrays actually can have the elements remaining, so we can push those elements into our resultant array. So you can review again that we will be actually comparing the array with the I and I value here and j here, and we will be comparing it, and it's more like a 2-pointer problem. So you will understand more while I will actually show off you the program and we can code together. So let's code together. Here we will implement the function merge arrays. So you can see array 1 is given and array 2 is also given. These numbers 1, 12, 14, 17, 23 for array 1, for array 2, 11, 19, 27. So let's solve the problem. We will need to have a resultant array. We will actually return the array which will be actually sorting out these two arrays. So first we declare the resultant array variable. It must have the size of array 1 length plus size of array 2 length. We must also declare two more variables because those would be the pointers I for array 1 and j for array 2. Now we will iterate both of these arrays. I should be less than array 1 dot length and j should be less than array 2 dot length. So we will compare both the element of these arrays. So we will compare array 1 index with the array 2 index. So if array 1 index is less than, it means that the first element or array 1 at particular index I is less than array 2 element which will be at index j, because initially both of them will be actually at the pointer pointing towards the index 0. So in that case we will actually push in our resultant array with the value. So it means that I will need to declare the variable for the resultant array too. So I will declare an int k is equal to 0. So it will keep the index of the resultant array. Right now it's an index 0. So I will actually declare with a variable k. So k should be equal to array 1 I. It means that we will push the element into the index 0 of the resultant array at the moment, and we will also increment the resultant array element with k is equal to k plus 1, because whenever we push it, then we should point to the second index of a resultant array after each pushing. And in this case, if I is less than, since element number 1 is less than the index 0 element of array 2, so I should be also increment. Now the other condition is it satisfies the first condition, so we implement the second condition. If array 1 index is not less than array 2 j index, so it means that we will push the array 2 j element, and in this case j should be incremented, array 2 index should be incremented, and k obviously will be incremented. So it's a basic loop, and we will return the resultant array. So we should return it. Always remember to return the resultant array, because in most of the problems while developer is resolving, they normally forget to return the resultant array. So that's why their result can be unpredictable. No, the other condition. What happens if there would be any remaining elements in the array 1 and any remaining elements can be for array 2, as we discussed, and in the previous diagram we discussed it. So in that particular case we will iterate again. So we will first sort out the case in the case if there would be any element remaining in the first array. So that will be the I should be less than array 1 length. So in that case we will actually push each element into the resultant array. So k should be the array 1 I. So I should be incremented and k should also be incremented. The same case will happen with the second array as well. So array to length resultant array So we will increment the j plus 1. That means that we will increment the index of a second array, and we will also increment the k. You will always see that either the array 1 would be empty or array 2 would be empty. It's very rare happening that both of them are not empty. Yeah, both of them can be empty, but it can be rarely happen that both of them would not be empty. But it would not actually unsatisfy our condition, because I will always be less than array1.length. It means that eventually we should need to push each element of any of those arrays. We will push each element of those arrays, so it does not make much problem. So we can also, you can see, we here I actually use these syntaxes as equal to I plus 1, and I can make it more concise. But let's run the loop. So you can see it, our program actually compiled successfully, and it is giving us a result. And both of these arrays are actually in sorted order right now. We can concise or make our program more clear. So here the resultant array I can actually put here k++ and I++, and I can remove it. What does it mean? It means that while assigning an integer at position k for the resultant array, it should increment k is equal to k+1. But after resolving this statement, and same case with array 1, so it will be incremented I is equal to I plus 1. But after assigning array 1 I to this resultant array, so this thing needs to be remembered, and it's a bit short syntax. Your k++ and I++, I don't need these. Now our program is more concise. Now let's run the program again. You can see it's compiled successfully. We can run it. But how does this loop work? So if we can also debug it. If we wanted to debug, we can actually make a debugger here, and we'll debug this loop. So you can see initially we are at index 0, and j will be also at index 0 in this position. So we will iterate over these loops. Array 1 element, that is 1 will be compared with 11. So 1 is less than 11, that's a true. So 1 will be in the resultant array in this case. Now you can see it, 1 is in the resultant array. And now the loop will run again. 11. Since 11 is lesser than 12, so 11 will be pushed into the resultant array, and the index will be incremented in case of array 2. We can say it, 11 is incremented. So if we go further, so in this case index here, that is pointing 12, because we are here in index 1 of array 1, and it will be compared with the 19, that will be at index. So 19 will be compared with the value 12. So 12 will be pushed into the resultant array, and then the index will be at 14. It will be increment the index for array 1. So let's see, step over, and we will increment the loop again. So here both of these arrays will be compared again, so you can see it, and then the 14 will be compared. So you can see, you will have an idea that how is this working. Now the index 5I, it will not work here because we have pushed all the elements of our resultant into our resultant array from array 1. So it will go here. Here j, you can see the value of j here, which is 2. So 27, that's the only element is remaining, and that will be pushed into the resultant array. Now we are returning the resultant array right now. So that's all. It's a simple program. Thank you.